Brett teaches Raspberry Pi.
Brett teaches Raspberry Pi.
Brett.
Tech is cool. T-minus 5 seconds.
Brett teaches Raspberry Pi.
Alright, let's continue here. So, if you notice, or I told you, if we moved a pixel off the screen, we would get a crash. So we need to go ahead and fix that and stop that error. So we're going to create some boundaries so you cannot run off the screen. It actually stops you from doing it. So first of all, I think we need to add some more colors to our program. So we're going to scroll up here and actually add more colors. So let's click over here and then scroll up. So we currently just have red defined. Let's add green, blue, and empty. So we're going to say G. So remember, it's red, green, blue as far as the colors go. So full green on that one. Blue is going to be 0,0,255 for max blue. And then we're going to do the empty. Or since we can't do blank, we're going to do E for empty. We're going to set that equal to 0, 0, 0 so that we have all of our colors available to us. Let's also add that matrix back in from our previous application. So we're going to start with our matrix variable. Remember, do the square brackets on this one since it is an array. And we have to do the 8x8 grid. So we're going to do this without the blue squares in the middle though. So all we're going to have is a bunch of green squares all around the outside edges, and everything in the middle is going to be empty. So do your 8 G's across for green. And then on the next row, you're going to do just the first pixel green, all the rest empty, the last one empty, or G, sorry, for green. And then repeat that all the way down for the next 6 rows. So green, empty, 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 green, etc., 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 all the way down until you get to the bottom row of this whole thing. So we got green, and then a bunch of empties. Okay, that was our 5th row. And then we're doing our 6th. Okay, a bunch of empties, green at the end. And then we're going to do another row, green, a bunch of empties. This is our 7th. This is our final row here on the next row. This one we want to do all greens to make sure we finish up that border. So green, 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 green. And then you don't have to do a comma at the end, remember. And then we're going to make sure to close this up with our curly bracket. But we should have an 8x8 grid there. And then we're going to close it by our square bracket. Sorry, not our curly bracket. Square bracket there to finish it up. And then as we get down here, we need to come down and actually draw this thing. So when we go to our update screen function, we need to make sure to call sense dot. And if you remember, it's set pixels with an S, and it takes that array in. So make sure we pass that matrix into it so that it actually draws it right before we draw the player. So we want the matrix to draw first and then the player to draw over the top of it so it overwrites the pixels. Okay, so we got that drawn now. Now we need to code the ability down here to actually stop the player from exiting the grid, hitting any of those outer edge pixels. So we're going to modify this loop down here where we're checking if the joystick was pressed. And so in there we're going to make sure that they aren't actually exiting the grid. So when we hit to the right, meaning the player is moving to the right, we know that the furthest pixel they can go to is 6 because 7 is the edge. So we're going to add another AND statement here. So if it's pressed and they've gone right, and we need to check for a positive statement, which means the player's X coordinate is currently less than 6. Okay, so if it's 0 through 5, it's okay for them to move right. If they're currently 6, they can't move to the right because that would put them in the border. We don't want them there. We're stopping them if they're at pixel 6 because they can no longer move to the right. Okay, and then we're going to essentially do the same thing on the left side. For the next one down. So remember, this one moves to the right is 6. If we're moving to the left, we can't have them be essentially 1 or less. So they have to essentially be greater than 1. So I'm just going to fix the spacing there. Let's do the next one. So we're going to say and player bracket, type player, here we go, bracket X, quotation X quotation is, as long as it's greater than 1, we're going to allow them to move to the left. So remember, as they move to the left, the pixels that are off limits are essentially pixel 0, and pixels, anything off the grid, so negative numbers. So if they're in position 1, they can't move to the left. And then we're gonna do the same thing for the down and up directions. So moving down, the largest the player Y can go to is 6 as well. So as long as it's less than 6, we'll allow them to move down. And then moving up's the same thing as the left. So if Y is greater than 1, we're gonna allow them to move over. So this is just setting up the boundaries all around there using this matrix up here to make sure it all works. So let's go check this out and see if it actually stops the player from exiting the board and test it out. So make sure you stop your previous program if it was running and then run the new one, or make sure to save it first and then we'll run it. Okay, now we got our boundary set. What do you say we go ahead and test that out?
All right, let's test it out.
Okay, running the application.
Just using this little joystick again. And look, it does not crash off or go off the matrix. That's
Absolutely. So you can push it toward the edges, you will not go out of it. So I think the next thing we do is make it a little more game-like. Let's add some fruit to it. What do you say?
great. Raspberries?
Blue raspberries.
Okay, let's add that fruit.
Okay, let's go do it.